So this discussion is going to go into the most fundamental idea of what are statistics and, what we're doing with this in terms of analytics. So analytics is going to be that scientific process of transforming data into insight to make better decisions. We have descriptive analytics, predictive analytics, and prescriptive analytics. For now, we're going to focus on descriptive analytics. So descriptive statistics are pretty much any of those things that kind of summarize data for you. So most of what you see in newspapers, magazines, company reports, or other kind of publications will be from descriptive or summary type statistics. And so oftentimes they're called descriptive statistics. They can be summary statistics. It can be part of what we call exploratory data analysis. So here we have an example where we have the manager of Hudson Auto Repair wanting to have a better understanding about the parts that are used in the tune-ups. And this person took a sample of 50 customer invoices and rounded the cost of parts to the nearest dollar. So here on this slide, we've taken all of these observations and listed them here for you. Then we can tabulate those values based on their frequencies and what we call the cumulative or the percent frequency. So we've taken the continuous variable part cost and we've now put them into bins or groups. So the first group is 50 to 59, the second 60 to 69, and so forth. Notice that the width of those groups are the same increments every time. And then we counted up the number of observations that fell within that range and calculated the percent frequency by taking the frequency divided by the total number of observations. You can also take these summary statistics and display it in a histogram where you can see the visually the distribution of the data within your different ranges. When we look at different data types, we can look at it in terms of scale, where we've talked about this earlier, where we talk about nominal, ordinal, interval, and ratio. Some things that we can do with nominal data is that we can look at our percentages. So we can look at what percentage of our population is male or female. If we look at a mode that occurs most frequency, we would do look at what tends to have more individuals from a particular demographic than others. But with nominal data, the issue with nominal data is that sometimes you're putting data into a spreadsheet, you have to code it. So for example, male versus female. You may have a 0 for male and a 1 for female in these cases. Yes, you have numbers to describe your data, but those numbers don't mean anything other than the arbitrary labeling that you've given to it. So you need to make sure that you're being careful when you're looking at the type of analysis that you perform when you have nominal data. Interval data is looking at your ordered relationship within a category. So you could be your attitude on a scale of 1 to 10. How happy are you today? The gap between 1 and 2 can be very different than the gap between 3 and 4. Or the divisions really kind of end up being kind of arbitrary, but there's still an order to your data. So with ordinal data, you can find percentiles. You can find the mean. You can still go back to the percentages and break them up into the categories like we did with the Hudson data. And then we have ordinary interval data. Interval data are ordered in terms of their relationship, but now you have an equal distance between each of them. So an example of that would be the temperature scale. So 1 degree Celsius is going to be the same when you're looking at the relationship between 1 degree, 2 degrees, and 5 degrees, and 7 degrees. So when you're working with intervals, you can calculate the range, the mean, and the standard deviation. And then our fourth scale is going to be the ratio scale. So they're still ordered in relationship to each other. We have those specific increments between our measurement values, but here our 0 value actually can be of use in this type of data. So you're looking at how much time has passed or how much something costs, the number of customers that we have. You can do all of the previous descriptive statistics in addition to being able to do the coefficient of variation on your ratio data. So when we're summarizing our data, summary measures allows you to take that set of data and, typically involving three main attributes that you want to look at, and discuss what your central tendency is, or how dispersed or how spread out your data points are, or what the shape of that data looks like. If we're looking to draw a line to describe our overall trend, okay? If we're looking at dispersion, we're going to look at how spread out your data points are. And your central tendency is pointed to trying to describe something about the middle points of your data. But each of these are going to be discussed in separate lectures. But all of those can be part of what we call exploratory data analysis. Exploratory data analysis is basically the starting point to become familiar with your new data set. You utilize your descriptive statistics and data analysis to allow you to make a connection between how the data was collected and then maybe how it can be analyzed in the future. So when you do your exploratory data analysis on a new data set, not only are you doing the mean, median, and mode, but maybe you want to look at the interquartile range, which is another measure of location that we'll talk about later. Or maybe you want to look at the correlation between the variables, just to look at the individual relationships. But exploratory data analysis is part of you doing analysis to become more familiar with the general trends of your data overall in preparation for the analysis for your research question.